towards the end, I'll give you some information on how to use Ganeti in Google. Seems like I have faulty feedback. And this is what, at the end, I will give you the place where you can get the source code of Ganeti and the roadmap for the future. What is virtualization? This is more for the people who don't have experience with it or want to know what virtualization is. It's basically an abstraction of the resources that computer has, like CPU, memory, storage, hard disks, or network. There are also other kinds of resources you can virtualize, but I will just mention these here. Advantages of virtualization are that you can consolidate several machines into one single machine and increase the utilization of that machine without any effect for the user or the application running on top of it. For most cases and most users, not all of them, it's transparent and you don't notice any difference to a physical machine. And it allows you to be rather flexible because you can move one virtual machine from one physical box to another one, and the system will be exactly the same afterwards. One disadvantage is that for certain workloads, it's not as fast as a physical machine. For example, if you depend a lot on storage, you may not get the bandwidth you need, or if you have timing constraints, you have to pay attention to those as well. Because virtualization, the virtualized software doesn't run with the same clock rate like the physical machine, but that's a technical detail. There are different types of virtualization. The most important ones are the full virtualization and partial virtualization. Full virtualization is what you may know from VMware or Microsoft Virtual PC, which basically virtualizes the whole system, and you don't need to modify the guest system. The guest system is the system running inside the virtual machine. You don't need to modify that. Whereas with the partial virtualization, which is implemented in like Xen or LGAST in Linux, you have to modify the guest system to run inside the virtual machine. But it will run much faster because not everything is virtualized. The most important bit of virtualization or the implementation of virtualization is the hypervisor. It's basically the core of every virtualization software. It is between the physical hardware and the virtual machine and takes care of all the virtualization that needs to be done. What is Ganeti and why should we use it? It's the software to manage clusters of virtual machines or virtual servers, as we call it. The automation that's built into Ganeti and you can use Ganeti to automate it makes it very easy to scale to hundreds of virtual machines and also hundreds of nodes if you want to. Everything is integrated into a single interface, and it's not like you have to write custom scripts which need documentation and a lot of maintenance, and for every company it's something different. Again, you have one software, Ganeti, which provides you most functionality you need, and you can even enhance it by using tools. Virtual systems are portable between the nodes, so you can move one instance from one node to another node if, for example, the original node has a problem, whatever problem that may be. The hypervisor interface in Ganeti is abstracted so that you can use different hypervisors or virtualization products. Right now, we only have an implementation for Xen, and there we have implementations for virtualization and full virtualization. And we also have a fake hypervisor, which is used during development, so then you don't need all the setup we authorized may need if sending. And it's very easy to write a new hypervisor interface. So if you want to use KDN, for example, or VirtualBox, which is also a full virtualization for that, you can more or less write the abstraction and use it. One more thing that right now we only have 10, but in the future we will have more of this here. Now I'm going to use a few terms that may not be known by everybody, and I just want to explain them. So a node in our terms is the physical machine. In the same terms, that's W, basically. It's the real machine. And then we have the instance, which is the virtualized system. And in Zen, it's called W. You can have several instances on top of a single node, but not the other way around. Then we use DRBD, which is a distributed replicated block device, and it's used to replicate data from one node to another on the block device level, which is for most people just a hard disk or a partition. And we use LVM for partition management so that we don't have to repartition the whole hard disk every time. And we can still use a single partition per instance. Now, I'm going to give a short comparison between one type of traditional clusters and Ganeti. In more traditional clusters, this is just one scenario. You could have others. You basically virtualize the application layer. So you fail over the whole application in case the original node has a problem. The disadvantage is that you have to install the operating system several times exactly the same, or you shouldn't have too many differences so that you can easily fail over if something breaks. And you have to take care to store application data, which is on the bottom here, on a reliable storage medium, be that a storage aggregator or your replicator, something that's just reliable. And then you use, for example, heartbeat or a manual process to fail over the application to other node if it fails. This is very error prone and doesn't really scale very well to a lot of applications. It may work for 5 applications, but if you are talking about hundreds of applications, that's really difficult. This is the Ganeti concept of a cluster. You have several physical machines, nodes, and then you have on top of those several virtual machines, the instances. And if a physical node fails or you have problems with the load on a single machine, you can basically just fail over an instance from another node. And it will continue to run there as if nothing happened. Then in Ganeti you have a single node or node role, which is the master node. It does all the checking and the control of the nodes. So basically it's the master node sends a command to the other nodes, do this, and the other node does that. So the master role takes care of everything. And you have to run the commands on the master node. But as is required in the cluster, you can easily fail over the master node to another node as well. I gave you a short introduction to Ganeti and the differences between more traditional clusters and Ganeti. I'm now going to tell you a bit about the design goals that were set during the development of Ganeti. One goal was to increase the availability of the virtual instances. So if something fails, you don't have to wait half a day or a day to just reinstall the machine, not even talking about getting new hardware. You just fail over the instance to another node, and the users just notice a short runtime, but not that much. It also reduces the hardware cost because you can run several services on a single physical machine while they are still in their own virtual system and don't need to feud with each other. Or you can run several different Linux distributions or operating systems on top of a single machine. And it increases also flexibility. You can easily move instances between one and the other node. And like I said, the users of the services on top of those machines don't notice too much. And as I said before, it's transparent, so in most cases, services just run on it as long as the underlying Linux or whatever operating system you use, distribution is usable for it. Principles. It was really important to say that we don't want to depend on expensive storage like a SAN or whatever it would be. Like even a RAID is quite expensive compared to using DB for application. And you must scale linearly with the number of systems so that you can add, you can manage hundreds of nodes with Ganeti. To make it a bit easier, we decided to not go for a multi-master system because that's quite difficult to get right. And failure is possible. The chances of a master node dying is rather small, as we have seen in Google during the last years. So it's not really worth to go for a multi-master system, and we just decided to go with a master role server, single machine. And since it's possible to fail over, it's not a problem. Redundancy. What is redundancy? You basically replicate something that's stored here to something else. In this case, disk is redundant, so everything that's stored. I'm sorry, confused. We want to. That's replication I was talking about. You replicate the data to a second node so that if the original node crashes or has, let's say, a power failure, you can just start it again on the second machine. Redundancy is you need to make sure that you have enough disk space and memory available, free available, in a cluster to be able to fail over instances. Depends on your SLAs, you have the service level agreements and then you need to define how much free memory you need. That's something you need to take care of in such a cluster. Because otherwise you may not be able to fail over all instances of a node that has problems. Yeah, and the failover is that you can easily fail over an instance from one node to another. Failover is basically just shutting down the instance on the first node and starting it again on the second one. You don't need to copy the data because it's replicated anyway. Once you fail over an instance, your original node is the secondary for it, and you can also fail over the secondary and move the secondary somewhere else. I will tell you an example of that later on. Yeah, now we're going into cluster setup, the administration example. Ganeti has a really simple interface for users, and it's all unified, so you don't have to learn a lot of new commands or learn how to use that script. Everything in terms of administration is done on the master node. This is the master node is the one with the role of the master, and you can fail over it as well. But I'm not going to give an example of that here. All commands have documentation in HTML format or PDF if you want to generate it. They support the --help command to get interactive help. GT cluster is used to more or less control the cluster itself. GT node is used to add, remove, or modify nodes that are already or should be in the cluster. GT instance is the most used command because you use it to modify, add, remove, failover an instance. Whatever you do with an instance, you do with GT instance. GTOS is used to manage the OS definitions you use. An OS definition is a set of scripts that are used to install an operating system on top of a virtual machine. And you can have several of those. GT backup is the part we use to backup instances to an image file, and depending on your OS definition must have those scripts in it so that they can export all data. How to set up a cluster? Here you see on the bottom 3 nodes. Let's assume they are not in a cluster yet. And then you run chain cluster init and the cluster name, which has to be DNS, on the first node. That's it, one more cluster. And then you add two other nodes, node 2 and node 3. And in the end, you get basically this picture of a cluster with 3 nodes. They don't have anything on them yet. It's just a cluster. And this is the GT nodes list command. And these are just arbitrary numbers, so they aren't real. But you can see that we have 3 nodes now. You see that free disk space, memory, free memory, and in the end, we see how many instances, primary instances and secondary instances, which is just how many data are on those nodes. Now we are going to add an instance with that command. It's basically an instance, and then you give the primary node call on the secondary node for the DLD disk template. And this system will be installed with the Edge OS instance, which in this case is Debian Edge, and it's named mail1. You can also use all of these templates. We also support the plain disk template, which is basically, it's not replicated just on the local base. It's not recommended to use that because you can't fail those instances to another node. But it may be useful for a test system. Depends on your requirements. And in the end, we have once I come finished, we have a cluster that looks like the picture below. Mail saves its data primarily to node 3, but yeah, the command is wrong. It should be node 3 colon node 2. And then all data is also replicated to node 2. And in case of failure, you can start the system on node 2. Once you have several instances on a cluster, you can list them. Well, you can also list one. As an example, I listed several instances. Here you see that we have different OS definitions. You can create your own for your own distributions or your own environments. In this case, we have 2 Edge instances, one SUSE with a IDE and one CentOS. If you need a Windows, for example, you can use the full virtualization and create a Windows OS definition if you want to. You also see the primary node of each instance. All are running right now of them, and they have memory assigned. What's very easy with Ganeti is to script with those commands. For example, the list command supports the separator parameter with which you can set a director to separate the values. In this case, we want to get a list of all the instances and the columns name, vCPUs, which is the number of virtual CPUs assigned to an instance, and the OS definition. No header, so you don't get the first line of the first example, and separated by the column. And then you can use that to write scripts or monitoring or statistics. In case of a node failure, in this case, power failure or power supply failure, hardware failure in general, the node may go down or may not be reachable anymore. Depends on the failure case. Failure case is one of the problem with clusters because you never know how a node can fail. Or you may know it, but it will fail something different. And in that case, mail1 is down, and it doesn't run anymore. Then you can fail over the instance to the original secondary node, and that will become the primary node of that instance. Node 3 will be the secondary node at this moment, but since it's down, you have to ignore consistency, which means it will not go check whether the data is correct. Once you have done that, you can also fail over the secondary node again, and now mail1 is running on top of node 2 and replicates its data to node 1. And node 3 is still not available, and you can replace it. Any questions so far? Yeah? Do we have microphones? Yeah. in Ganeti because it doesn't know what system runs inside the virtual machine, and such errors could just be replicated. That's true. But it would also happen on a physical machine. So that's not the target for Ganeti to solve. But in this case, you could run two instances of the same system on a cluster, and if one fails, you can just use the other one. For example, use that for Ella. You shall have one instance bring the primary, another one secondary. If one goes down, you just use the other one, vice versa. Does that answer your question? Welcome. So this was the administration part, and now I'm going to show you a little example of how we use anything in Google, which I guess most people are interested in, because it's Google. We run Ganeti in most cases on top of 20 node clusters, which is more or less one rack of 20 machines, each 2 units high. We run a 64-bit Linux operating system with Zen on them, on those machines, and more or less 80 instances. This means 4 virtual machines per physical node. It's only used for internal systems, so if you go to Google.com, you will not access something running on Ganeti. I just have to make that sure because most people assume the other way. And it's used and targeted for non-resource intensive systems like DNS, HTTP, NTP, or anything like that doesn't use a lot of bandwidth on disks. You can try it yourself, but depends again on what you want to use it for. So you can use it for build systems, for example, but you have to monitor everything and make the test to try to ensure that you don't saturate bandwidth used for other systems. Ganeti itself is open source and can be downloaded at the URL. It has been open sourced in last August under the GPL2 license. And we take contributions from example developers. I guess there's even one in here who works in some parts of Ganeti. And right now we are working on, or starting to work on Ganeti 1.3, which will bring quite a lot of changes towards the model we have. And originally in February, in December last year, we released Ganeti 1.2, and in February 1.2.3, which contained quite a few bug fixes and other productivity increasements. Roadmap, the future. Right now, Ganeti, if you run one command, it gets a lot cluster like a single log, and you can only run one operation at a time. This means if you are adding, let's say, 10 instances, and you want to list all nodes because one failed, for example, during that time, you can't really do that. Then you have to stop the other operations first. So we want to implement a job queue, which basically takes the job and executes it when it's appropriate. And you can still run other commands like listing nodes or instances during that time. We need granular logging for that. That means we don't have a cluster-wide log anymore, but many small logs in various places of the cluster. All those logs will be on the master node and also be fed over to other node job queue will be replicated to alternate nodes so that if the master node fails, you can fail over and continue where you left off. What we also want to implement is a remote cluster API. In fact, we even have the first implementation in the Subversion repository since like a week. It will be a REST concept-based API to control the cluster. You can list instances, you can add instances using that API, and use it to automate it even more and more easily than with the command line commands. because you can call them from another node, from another machine, or even some script. What you don't have right now is file-based storage is, so you don't need any partitions anymore or physical disks, but you can just use a file on a SAN, for example, to store your instances data. And that file will not be replicated because that's the task of the system or the method you use to store that file. Failover is not implemented in Ganeti 1.2 because of several different difficulties with extend interface. But in 1.3 we will have that, and you will be able to, as long as the original node still runs, failover the instance from one to the other node without downtime. Right now, the instance of the original node has to be shut down and be started again on the new node. That's a bit of a problem. In case of a failure, you may not be able to failover, do a live failover anyway. You have to start it again. What we also want to implement is the ability to use multiple coexisting hypervisors. Right now, we only have a single hypervisor per customer, and that's fixed. If you want to have several hypervisors, you have to set up several clusters. And since a single node can only be part of a single cluster, that means you have to double the amount of machines in that case. Yeah, and